All right. Okay. Good morning, good afternoon, good evening, depends on where you are. And so today I'm very happy to join this meetup and to share my experience with using machine learning, particular unsupervised machine learning in the field of IT operations. So I have been doing research in this area in the past 15 years. Starting from IBM research, I started to use machine learning algorithms, particularly supervised machine learning, to study how to predict system problems and detecting anomalies. After about like 4 years at IBM research, and I left IBM and joined the North Carolina State University as a professor. Because I want to focus on this idea and establish a research program surrounding that. Since then, so our research has been funded by government funding agencies like National Science Foundation, and as well as companies like Google, IBM. So mainly we trying to use unsupervised machine learning to predicting system problems and diagnose system issues. So some of our research, got published and get news coverage, and we start to get approached by companies to see how we commercialize the ideas in the real world. So one of the companies is actually Google. About 2013, I think we start to, so our university filed a patent on one of our anomaly detection algorithms. And then Google started to actually interested in evaluating the technology in the cloud infrastructure and see how we can help them to improve the reliability of the Google Cloud. Then after that, it was a successful evaluation. Google actually licensed the technology. And so I was lucky to get some funding from National Science Foundation to bootstrap InsightFinder, which is a startup company I founded in 2016. So the company is commercializing the ideas we developed in my research lab. And so we develop products, nowadays it's called AIOps products, to help the operators to predict and prevent IT incidents. So at a very high level, the mission of InsightFinder is to develop innovative AI technologies to help the customers to achieve zero downtime. So they have, nowadays everything is digitized, right? So all the business running on top of IT systems. So when IT systems went down, business suffers from huge financial loss and brand damage. So minimized downtime is extremely important for almost every company. So how do we reduce that downtime is actually a very challenging problem, right? So nowadays, a lot of companies, they hire, an army of, site reliability engineers to manually watch their infrastructure. And if something goes wrong, then the on-call engineers has to, get online immediately and fix the problems. So this kind of approach is very reactive, right? So first of all, when the SRE got a page, something already happened. So your system is already down. Business already suffered. And second is that when you're trying to diagnose the problems, when system is already down, it's really hard because you lose all the data and the information and the context you need to troubleshooting the problem. So InsightFinder trying to change this completely, right? So we want to change from the reactive failure diagnosis and the recovery into proactive prevention. So we can predict production incidents hours before they happen. And we can provide automatic root cause analysis to help the operator to pinpoint the problems in minutes, rather than they have to spend hours in the war room to try to figure out what's going on. And the prediction can be used to enable auto remediation, right? So when something is, when the system has some minor issues, and if the InsightFinder predict there's some big service outage will follow these minor issues, it will trigger some actions to automatically remedize these minor issues. So before it propagates into some major service outage. We also have very easy integrations with all kinds of data sources. So that's basically one of the things for AI is that you need the data. And so in the AIOps domain, we have a very unique problems, right? So we don't lack data. So we are dealing with a huge data problem, not just big data problem. So we're dealing with high dimensional data space, that's basically involves millions of dimensions. And the other thing is that we are dealing with very dynamic systems. So the data are highly fluctuating, data are very diversified. It comes from all kinds of, comes with all kinds of formats. So those are all the challenges with the AIOps solution. So, so before I actually talk about how we do this, I want to actually talk about why we do this, right? So, so it comes from the challenges I kind of see in the IT systems, about 15 years ago. So compared to the today's infrastructure, 15 years ago system is not that complex. However, with the distributed systems, right, about 15 years ago, you don't have containers, you don't have virtualization, you don't have cloud, you have web services. And just with the web services, right, I was working at IBM. So just, at that time, one of the key products IBM provides is called the WebSphere. It's kind of like a middleware platform provided by for web servers. And just for that kind of like maybe a small distributed systems, right? And you are dealing with hundreds of parameters you need to tune in order to get the good performance. So that's the complexity that we already see kind of the initial problems. But today, you are at a stage that, you are dealing with much more complex systems, right? We have a lot of new technologies developed in the past 15 years. So there are a lot of challenges actually facing the IT operations. So the first one is that you will see the data coming from all kinds of different sources, and the IT operations has all kinds of tools to monitor different data. So the problem is that each of the tool gave them the one partial view of their systems. And so because of those incomplete picture, and it's really hard to actually connect the dots and to figure out, okay, where is the problem and how the problem starts. So the second thing is that, without a good AI technology, so the current way to detect anomalies is actually pretty, kind of empirical, right? So essentially what the operator does is to set up some thresholds based on their experience, and then and expecting those thresholds will raise alerts that they want to see. The problem with that is that it's really hard to set the thresholds for millions of hosts and tens of millions of metrics, right? And given a dynamic systems, it's really hard to actually say, okay, what's the right threshold to set, right? And the system are highly changing, right? And the time varying. For example, a 50% of CPU utilization might be perfect normal for my Monday morning service. But if I see this 50% CPU usage on the Sunday evening, that could mean some big issues happening. So as you can see, this threshold is not static, right? And it's you have to actually learn that from the real system behavior, rather than just setting a static single threshold for all the for all situations. And because of lacking a good anomaly detection tools, and so most of the time the operators has trouble to figure out what's going on, right? So they are, when some production incidents happens, they basically receive hundreds of thousands of alerts at the same time, and it's really hard for them to say, okay, where to start to examine this problem. And a lot of issues are still resolved, manually. So the companies are facing like a huge, cost to hiring, hundreds of thousands of SREs to watch their infrastructures. And it's not only, it's very costly, but also it's really hard to find those people. There's a talent shortage on, how to properly watch those systems. So that's where InsightFinder comes from, right? So we developed this AIOps platform to address all of those issues. So we address these issues from different angles. The first one we do is to unify the view. So if you want to do data analysis, and the most powerful data analysis is that you can actually combine the data from different aspects and to construct a holistic view for the analysis. And the second part we do is to do automatic anomaly detection, right? So the truth is that the majority of the time your system is normal. So it's really hard and to basically say, okay, this is abnormal beforehand, because if you know that means you already know this issue will happen, and the majority of the time you don't know. So anomalies are rare events, but normal behavior are common, and you have lots of normal data. So that basically provides opportunity for unsupervised machine learning. So we all know for machine learning, if you use supervised learning, the key thing here is that you need to get a good quality of labeled training data. And however, it's really hard to get labeled training data for our problem, because the data volume is just gigantic. Data are highly fluctuating, and it's going to be extremely labor intensive if you want to label some training data. And so in this case, typically supervised machine learning doesn't work in practice. So that's why we actually focus on unsupervised machine learning, because we have tons of normal data, right? And we can develop very good algorithms, very good models to extracting normal behaviors. And so for anomaly detection, then you just need to say, okay, when you detect it deviates from the normal behaviors, and how it deviates from the normal behaviors. So that's the third piece, that we can help the customer to pinpoint the root causes by ranking those anomalies and figure out the causal relationships between anomalies with the incidents. And then finally, we help the customer to deploy self-healing actions so they can actually prevent the problems completely. So all in all, InsightFinder provides this closed loop incident management solution, starting from the incident detection, prediction, and root cause analysis, and to prevention. As I mentioned, I have been working in this area in the past 15 years. We published over 80 research papers in this area. So we invented a set of unsupervised machine learning technologies. So compare with other approaches, so we have two unique features in our algorithms. So the first thing is that we can provide a real-time analysis, right? So this is a hard requirement for AIOps, because if you want to predicting system infrastructure problems or application performance issues, you need to do this in real time, right? It's useless you predict, okay, something will happen yesterday. So a lot of machine learning algorithms, like deep learning algorithms, they require large amount of training data, and it takes a very long time to train, and it requires very expensive hardware like GPU. So all those requirements make them like impractical for AIOps problems, because we need to deal with like, tens of terabytes of data, and we need to deal with like millions of dimensions. And it's also challenging for customer to invest like, hundreds of thousands of dollars in the hardware just to get the prediction done. The second thing, it's very unique in our problem, is that we need to be able to adapt to changing environments. So we support continuous behavior learning, right? Because the systems are not static, it's changing. So you need to be able to capture those emergent behaviors and to evolve your model or create model ensembles to capture different behaviors. So we have a set of patents in this area. So the first patent is based on the research we have done in the university. So as I mentioned, this patent is licensed by Google, and also right now InsightFinder is the exclusive licensee of this technology, and we use it as part of the InsightFinder products. We also develop a set of other patents surrounding the root cause analysis and the incident prediction prevention. Any questions? Please feel free to stop me. Yeah. Okay, if not, I'll further go on here. So I'll just give some kind of very intuitive results, how this algorithm is different. So DBScan is a very commonly used clustering algorithm. So a lot of companies like Netflix, Datadog, they try to use this algorithm to do anomaly detection in their products. The benefit of DBScan is that it's relatively fast compared to a lot of other clustering algorithms, and also it's a density-based clustering algorithm, so it doesn't require you to specify how many clusters you have in your data, which is a fundamental challenge for clustering algorithms like k-means. However, DBScan do have actually two weird parameters. One is called the mean points, one is called epsilon. If you're not familiar with these two parameters, you probably don't know what does it mean and what's the proper value I should set for my data. So I gave two examples, right? This is actually this is a data set coming from a real Cassandra cluster problems, right? It's a small 5 nodes Cassandra cluster, and one of the Cassandra nodes has actually problems during a period of time. And so as you can see in the top one, this is the results actually produced when we set the mean points 5 and epsilon to 1. And so what you see is that the algorithm flag everything as the anomalies. So the yellow bar on the top indicating which data points are anomalous. So everything is flagged as anomalies, right? So apparently this is useless. So then I don't know how to set these parameters for my data. So what I did is that I just increased the epsilon a little bit to 50. And I do see like much less anomalies. And then when I zoom in, I notice basically it detects some spikes, but the true anomalies is actually here. And for whatever reason, it didn't detect it by the algorithm. So this is basically the common issue with the anomaly detection algorithms using machine learning technology. And particularly for a clustering algorithm, so this is called the curse of dimensionality. So typically for clustering algorithms, if you look at over 20 dimensions, the accuracy of the algorithm quickly drops. So not only you see the problem is that you need to have very complex parameter tuning process, right? So the results are highly sensitive to the parameters. And in the real production environments, obviously you don't have a chance to tune your parameters, right? You cannot say, okay, for this data, on this day, I'm going to use this parameter. On next day, I'm doing different parameters. So it's really hard. So Netflix actually published some article to address this problem, is that they basically try 1,000 parameters at the same time and pick the best one they think. The problem with that is that, you know, it's very expensive, right? You need to literally run 1,000 times of the anomaly detection algorithms. And this complexity of this algorithm is also pretty high. So, so that basically makes this algorithm is really hard to apply to the real data set. So this is our algorithm, right? So we don't have any weird parameters to tune. And you can see we don't have that kind of situation like you detect everything or you detect nothing. And most importantly, the true anomalies is here on one of the cluster nodes. And the UBL can actually accurately pinpointing that node, and also pinpointing the top issue is the CPU and the memory. So so we have been developing these products, and so our customers are global leaders ranging from telecom to technology to finance institution and to technology companies. So those companies have using our products to do anomaly detection, prevention, and root cause analysis. And so as a data scientist, and you probably encounter these anomaly detection problems under different situations, right? It's a very common problems in pretty much all the sectors. So if you want to try out our anomaly detection algorithms, we offer free trials. So feel free to contact us if you want to try it out on your data. Just to kind of summarize some unique features you will get using our product. So first, I already mentioned it's an unsupervised machine learning. It's also multivariate machine learning. So machine learning has, you know, univariate analysis and multivariate analysis. So typically multivariate analysis is a lot harder than univariate analysis. And the benefit of multivariate is that you can actually detect the problems that you don't see in univariate. And also it's much more scalable because you can process all kinds of data at the same time. The second part is stream processing, right? So most of the machine learning algorithms are kind of a batch processing. You get the training data, you train a model and use it for detection. But you know, in the continuous online learning situation, right, you want to continuously detecting anomalies, predicting problems, you need to do stream machine learning and stream detection. And we can process all kinds of data, including like, you know, numerical data like a CSV data, or unstructured textual data like a log data, or semi-structured data like trace data. And we also provide active learning in our product. So this is actually a very new feature and concept we developed recently. So the idea is that, you know, the anomaly detection algorithms can never be actually perfect, right? So you always have false positives, some false negatives. So it's important for the algorithms to learning feedback from those false positives and false negatives to continuously improve itself. So by having this active learning capability, the model can increase, can continuously improve itself, right? Maybe when you first install InsightFinder, you will see about like, you know, 60%, 80% accuracy, but over the time, the accuracy will improve. So we can actually help the customer to predict the incidents, right? So we're not just actually detecting anomalies, but also, you know, predicting what is the problems following those anomalies and achieve the ultimate incident prevention. So there are several like products in this space. Just to give everyone some idea, what does AIOps do, right? So using AI for operation, you can use it pretty much in this 6 capabilities, and everybody start from alert reduction. So essentially, you know, you have a lot of alerts. How do you dedupe them, consolidate them into less alerts, right? So this is basically a standard feature pretty much all the AIOps platform provides. And the second step is basically you provide the correlation. So you can correlating what event is related to what other events. So correlation is a kind of like a simple, you can think about it as a simple, combination analysis, right? And I would like to emphasize correlation is different from causal analysis we are doing here. So causal analysis means that what actually happens before what. There's a strong causality between these two nodes. Correlation could just means co-occurrence, right? It could be completely accidental. Like when you have the incident issue, you have a CPU spikes here. So they could be correlating with each other, but it doesn't mean that has a strong causality. So what the customer wants is actually automatic root cause analysis, right? That's a causal analysis we're talking about. And then on top, once you know the causality, then you can do prediction, right? You can see, okay, when you see this anomaly, you can predict what incident will follow that. And then we provide this unsupervised active learning capability to continuously improve and then help the customer to achieve auto remediation. So in our product, the key thing here is we have this unified intelligence engine. This engine includes two parts. These are basically mainly analytics parts, right? The AI part. So the first engine is doing this unsupervised behavior learning. So it can consume all kinds of streams, log streams, metric streams, and we detect anomalies in those different streams. The second engine is basically doing this holistic causal analysis. So by this causal analysis, we can figure out, okay, what anomalies are highly related to these different incidents. And then based on that, we can do root cause analysis and incident prediction for the customer. So we provide a fully distributed infrastructure for this engine. So one of the things very important for AIOps, you need to be scalable, right? So like I mentioned, we need to handle tens of terabytes of data per day. So it's important to develop the scalable AI models that can handle large amount of data in real time. So you need a very powerful distributed platform to support that. And we developed this AIOps platform from scratch based on the specific needs of this large amount of real-time machine learning. So it's different from the other platform you probably heard, like Hadoop and Spark. Those platforms are not invented for stream machine learning. So they will have, they will suffer from the real-time performance problems when you deal with like real-time machine learning. So we do actually stream machine learning, like I said. So essentially all the data actually organized in a stream fashion. And also at the same time, our analysis has to support like event-driven query from the user, from the environment. So the workflow is kind of a hybrid, combining both like asynchronous event-driven architecture with the stream machine learning. Some case studies at some of our customers, right? This is example of the Fortune 50 tech company. So we actually integrated with ServiceNow for incident tickets, and we integrate Science Logic and Prometheus to get their metric data. We integrated with Elastic for the log data. And during this evaluation, we showed that we predict all the severe incidents in their infrastructure. We can achieve 2 to 12 hours lead time. And we help them to reduce the tickets by 70%. And we can provide the actionable predictions with relevant root causes. So this is actually some examples of the service outage we saw in some of the customers. So we see is that, the problems start from like, a subset of the nodes, right? The HA proxy is one of their gateway in their services. So they have 35 HA proxy nodes, and 2 of those has problems, and it bring down the whole services, right? And so it took them like over 19 hours to recover this problem. And with InsightFinder, we help them to pinpoint in the problem 7 hours ahead. And they know now, okay, when HA proxy encounter these kind of problems, they will have a service outage down the road. They can now prevent the problems from happening in the future. So this is some examples from our financial industry companies, and we kind of analyze the some of the batch jobs they need to finish every day. And so some of the batch job failures happened and took them like, took 12 people over 10 hours to fix the problem, to troubleshoot and to fix the problems. And again, using InsightFinder, they can actually detect the problems 12 hours ahead and pinpointing the exact nodes that which one has a problems. This is example from a prediction from a log data, and it's we analyze their application logs, and in that logs we figure out some exceptions that actually cause their outages. Okay, so this is basically a quick summary of what we do, and so like I said, we offer free trials, and if you are interested in trying some anomaly detection algorithms, feel free to go to our website InsightFinder.com, request for a free trial, and you can upload your data and see some anomaly detection results yourself right away.
Thank you. There is actually one question, if you can look at it in the Q&A session. Mm-hmm. So there is a demos on the website, or?
Yeah. So if you sign up in our website, you will see a demo system yourself. Yeah.
So you are integrating that platform to like the company's products, or?
Yeah. All the technologies we developed is in our products. Yeah.
Is it kind of subscription model you have, or licensing model?
Yeah, we do subscription. We are SaaS. Yeah.
Okay, great. Yeah, the question. Yeah.
Yeah, I'm reading the question. What's this? ML algorithm were known to have difficulty with explanation. Yeah. So so the RCA analysis, basically we that's what I'm saying is about the causality, not correlation, right? Correlation will find out a lot of like root causes. It doesn't make sense to the user. But if you do causal analysis, most of those algorithms, most of the kind of root causes we come up with are self-explaining. We also provide the the context and the data for them to see, okay, how this, for example, we detect some rare events and or basic high events, and we show them the context. Okay, what is surrounding that? Why it looks like rare or hot? Or like we say, okay, CPU is a normal CPU here, and then we also give them the normal range, right? So how is it different from the normal? So the second question is, do we have problem with false positive rates? So that's like the key problems in the past algorithm, like I was talking about, like for the clustering algorithm, there are a lot of false positives, right? Because if you want to detect something, you have to actually use a very sensitive parameter, and then basically the result is that you have a lot of false positives. The other issue also is that most of the algorithms, like the clustering algorithm I was talking about, they typically, you need to load all the training data and then you do analysis, or kind of like a mix the training and detection together. And if you have a large amount of data, like a lot of dimensions, it's really hard to load all the data in the memory at one time. So what people does is basically doing either sampling or data partition. And so they basically sacrifice the fidelity of the data and to fit their resource constraints. So that's the other key factor why basically they suffer from high false alarms. So because we are doing straight machine learning, so which means the data coming into our model and the model basically learn that, and then the data we throw away. So we can later do sample by sample training. And so we don't lose any fidelity. We learn all the data. And also the algorithm we developed is basically very robust to fluctuation in the data. So we are not going to capture those spikes, minor changes, like we capture the principal changes in the data.
There's also questions in the chat.
Do you conduct interventional experiment? Do you conduct interventional experiments in their systems to do the causal analysis? I assume that means for injection. Can people talk actually? Or just
actually, if they raise their hand, we can let them talk. Yep.
Okay.
Yep.
Yeah, if the interventional experiments means for injection, the answer is no. We don't disturb our, because our system typically used in the production environments. We don't do any changes to production environments. So we only learn what actually happened. So this is basically the key challenges for a lot of machine learning model. They don't have enough anomaly data. That's why we take the anomaly detection approach, which means we are not learning the anomaly data only. We are learning mostly the normal data. Yeah.
Okay. I think that's the questions we have. It was it's very good, great product, and I also love to try. We have different teams. I will ask them to try the product as well.
Oh,
and
cool.
There's another question, Christian. So before we close, he asked, "Do you have the manual calibration by the client? Do you have to do manual calibration by the client?"
Manual calibration? Not really. We basically the key thing here is unsupervised machine learning. So we don't require the customer to calibrate the model. That's the key thing, right? The model is self-learning, self-calibrating in a sense that we take the feedback from the environment and to improve the model itself. So.
Yep, that's great. Thank you, Helen, for the talk. I like the product, and I like to actually keep connected with you. We may have different things, we may collaborate. It's a really great product. Excellent work. Thank you, everyone, for participating. And just we are planning more events for the summer. Please just continue to participate in our events.
Yeah.
Have a great rest of the day.
Thank you. Thank you, guys.
Thank you.